This video is for the foldable real number systems. So we're going to start off with rational numbers, and all these are going to be definitions. So what you might want to do is to pause the video so you can write down the definition, and then you can start it back up to go to your next definition. So a rational number is a number that can be written as a ratio or a fraction in the form of A over B. So there's lots of different numbers that can be written as a fraction. So all of your whole numbers, so for example the number 4, can be written as a fraction, 4 over 1. So that would be a rational number. Integers, so -3, can be written as a fraction, so -3 over 1. Decimals, so 25/100ths, can be written as a fraction. So those are rational numbers as well. Now when we deal with rational numbers that are decimals, there are two types of decimals here. There's terminating decimals, and that's a decimal that ends, so for example 5/10, or a repeating decimal, and this is a decimal that repeats indefinitely. It means it goes on and on forever, but it's the same pattern. So again, if we look at the example 1/4, that gives me the decimal of 25/100ths. That's a terminating decimal. It ends there, it doesn't go on anymore. But 1/3 is a repeating decimal, and that's the 0.33333, on and on and on forever. So you can use the symbol for repeating decimal, which is a line above the number, or if you write it this way with the dots, that's also signifies that that's a repeating decimal. Integers include all of the whole numbers and their opposites. So the opposite of any whole number is going to be a negative number. So integers are going to be -3, -2, -1, 0, 1, 2, 3, and on both ways. So if you can remember all the whole numbers and their opposites, that's the best way to find your integers. Now whole numbers are all your natural numbers and 0. So those are what your whole numbers are. So 1, 2, 3, 56, 72, 89, these are all of your whole numbers. And then your natural numbers are going to begin at 1 and increase by increments of 1 each time. So your biggest difference here between whole and natural is the 0. 0 is a whole number. That is not a natural number. Natural numbers start at 1 and they increase by 1. So 1, 2, 3, 4, 5, 6, all the way to infinity. So the new category that you learned this year are irrational numbers. So all numbers that are not rational are considered irrational. An irrational number can be written as a decimal, but not as a fraction. So that's really important. If you can take a decimal and you can turn it into a fraction, then it is not an irrational number. An irrational number has endless, non-repeating digits to the right of the decimal point. So whereas our rational numbers were terminating and repeating decimals, irrational numbers do not terminate and they do not repeat. There is no pattern, there is no rhyme or reason for what the next digit is. So some really good examples here. Pi, anytime that you see pi, that is going to be an irrational number, and pi simplifies down to 3.14159.265, and it keeps going on and on forever. There's no pattern there. So anytime that you see any number tag teamed with pi, so 2 pi, that would be irrational. 3 divided by pi, that would be irrational. Another good example, the square root of 2 is a common irrational number that they throw out there to you, and you're just expected to know that the square root of 2 is irrational. And if you would put this one in your calculator, you would get 1.414, and again, it's going to go on and on forever. Now the little trick that they love to do is give you something like this, the square root of 4, and you immediately see that square root sign and you go, oh, that's irrational. But not in this case, because the square root of 4 is going to simplify down to a 2. So always keep that in mind. Always check it with your calculator before you immediately determine that that's an irrational number. So now let's practice a bit. So we're going to name the set or sets each of the numbers belong to. Be sure to account for all sets. So here's what this means, guys. If you go back to the front here, you've got this Venn diagram for your rational numbers. So how I used to describe this was like clubs. So a whole number, or a natural number, 2. 2 is a natural number, but if you notice, it's also inside this whole number club. It's completely circled by that whole number. So 2 is also a whole number. It's also circled completely by this integer club. So 2 is also an integer. And then finally, it's completely circled by that rational number club. So it is also a rational number. So 2, when you classify that, is natural, whole, integer, and rational. Okay, so 0.875, that is going to be a real number, and all numbers that we deal with this year are real numbers, and it's also a rational. Number 2 is a 0, so we know 0 is not a whole number, but it is real, it is rational, it is an integer, and it is a whole number. All right, 17. 17 is a natural number, which means it's going to fall into all the other categories. So it will be a whole number, it will be an integer, it will be rational, and it will be real. All right, the square root of 10. Now, if you put the square root of 10 into your calculator, you're going to see that it has a decimal that goes on and on forever, but it does not repeat. So the square root of 10 is a real number, but this is an irrational number. And that's the only category it can fall into. You can't be irrational and rational at the same time. All right, -2/5. This is a real number, but this is rational. And one of the biggest mistakes I see is because of this little negative number. You automatically see that negative and you automatically say, oh, that's an integer. Not the case here, because 2/5 is not the opposite of a whole number. All right, -29. This is going to be a real number. This is going to be a rational number. And this one is an integer because the opposite of -29 is +29. So it's the opposite of a whole number. All right, number 7 says the square root of 81. This is the one I was warning you about. If you simplify the square root of 81, you get a 9. And 9 is natural. So the number 9 is natural, whole, it's an integer, it's rational, and it is a real number. All right, number 8, 0.7 repeating. Now, since it repeats, that's going to make it rational. So this is real and rational. 9 is pi. We talked about that in our examples. So 9 is a real number, and it's irrational. All right, number 10. What happens if you get a bad boy like this? You get a mixed number. Again, the mistake I see, you automatically see this whole number here, and you say, oh, that's a whole number. Oh, that's a natural. No, because it's attached to a fraction. And if you simplify that, you get 8.75. Anything that's got these decimals trailing along at the end is going to be a rational number. So 8 3/4 is real and rational, and that's as far as that one gets to go.